Question number 4. In a large population, the systolic blood pressure of the adult is normally distributed with the mean 125.4 and standard deviation 18.6. Find the probability that the systolic blood pressure of a randomly chosen adult is less than 132. Okay, so here mean we denote by this mu, and it is given 125.4, and standard deviation we denote by sigma, and it is given 18.6. Now x is normally distributed. Here your x is normally distributed with mean as 125.4 and sigma square as 18.6 square, we can say. Okay, find the probability that systolic blood pressure of a randomly chosen adult is less than 132. We have to find the probability of x less than 132. So this is same as probability of z less than. Now here probability of z less than 132 minus 125.4. Now here you may ask me a question that why we are not applying the continuity correction over here, right? Why we are not applying continuity correction over here? So the answer is simple. Whenever there is a problem of approximation, there you have to apply continuity correction. Here uh, they themselves are saying that we have to find possibility of x less than 132. Okay, and this is purely a problem of normal distribution only. So if they want less than 132.5, they have mentioned it like less than 132.5. Okay, so probability of here z less than. Now if we calculate, it is 132 minus 125.4 divided by 18.6. So 0.355. 0.355. We have to find probability of z less than 0.355. Now probability of z less than 0.355. This is your normal curve, and z less than means here z is 0. Here we have z as 0.355. I am saying that less than means this area we have to look for. Okay, so this is phi of 0.355 only. Okay, so let us see this particular chart and 0.355. So 0.355. So 0.3 is here, 0.3, 1, 0, 1, 2, 3, 4, 5, and one more 5. So here in difference 1, 2, 3, 4, 5, 19. I will add 19. So 6, 3, 6, 8. We add 19 to it. 6, 3, 8, 7. So we will get answer as 0.6387. So up to 3 decimal places you can round, and you can say that 0.639. Okay. Now second part of the problem, the systolic blood pressure of 12-year-old children in the same population is normally distributed with mean 117. Of these children, 88% have systolic blood pressure more than 108. So here again, mean is given 117, x is normally distributed with mean and variance. Okay, mean we know that it is 117. Probability of x greater than 108 is given 88%, means 0.88. What we have to find? We have to find standard deviation. Sigma we have to calculate. Okay. So probability of x greater than 108 means what? It is possibility of z greater than 108 minus 117 divided by sigma. And this possibility is 0.88. So here this 108 minus 117 is negative 9. So negative 9 divided by sigma will be equal to, now if we look at the chart, so this is probability curve. We want p greater than 108. So 117 is this mean value. So 107 is certainly somewhere here, 108. And I have to find greater than 108. So this area I have to look for. Okay. Now here the z value is going to be negative. All right. This is minus 9 divided by sigma is equal to, now this is z part now. So z part is equals to for 0.88 whatever I get, I will take negative sign for that, for 0.88. So 0.88 is, now look here, we have 0.8790. So I have to add 10. So this is fifth position. So 1.1, then it is 0, 1, 2, 3, 4, 5, 6, 7. Okay, 1.175, 1.175. So it is 1.175 minus 1.175. Okay. So therefore the sigma value will be 9 divided by 1.175, 7.659 or 7.66. So 7.66 is our variance. Not variance, it's the standard deviation. Okay. Now the third part. 3 adults are chosen at random from the population. 3 adults are chosen at random from this population. Find the probability that each of the 3 adult has systolic blood pressure within 1.5 standard deviation of the mean. So first I will find what is the probability that the systolic blood pressure is between 1.5 standard deviation of the mean. So that means probability of z we have to find greater than minus 1.5, less than plus 1.5, right? Within 1.5 standard deviation means your z will be greater than minus 1.5 and less than plus 1.5. So if you see this particular diagram, so you have to find something like this, the value between this. Okay. So this is equal to what? Means this is 1.5, here it is minus 1.5. Okay. So from this whole value, like if I take this whole value, from this whole value I have to subtract this part. Okay. So that we can say that this is phi of 1.5 minus, I have to subtract, that means 1 minus phi of 1.5. So this will be equal to 2 times phi of 1.5 minus 1. Okay. So 2 times phi of 1.5 minus 1. So this is equals to 2 times. Now phi of 1.5. So phi of 1.5 is 0.9332. 0.9, 0.9332 minus 1. So this is equals to 2 times 0.9332 minus 1 is 0.8664. So this is required probability. Find the probability of each of these adult has SVP within 1.5 standard deviation of the mean. Getting it? Now, let us come to the problem. 3 adults are chosen at random from this population. Find the probability that each of the 3 adult has SBP within this range. So this is the possibility of having SBP. Okay, just a minute. My battery is running out. Okay. Fine. So here, the possibility that find the probability that each of these 3 adults has SVP. So 3 are chosen and all 3 has. So probability that each of 3 has SVP within 1.5 standard deviation will be equal to, for first person it is 0.8664, for second person it is same, so I will multiply, and for third also it is same, so I will say that 0.8664 power 3, and I will get 0.65. So 0.65 is required answer. 0.65 is the required answer. Done.